Hey everybody, welcome to your online version of Math 0314 Intermediate Algebra. Okay, so today we're going to start with, I hope you noticed, or maybe you noticed, that the title of this chapter was more on solving linear equations. Okay, so that gives the indication that they expect you to really know how to solve a linear equation. So hopefully this is just a review. Now here's the steps that we're going to practice for solving a linear equation. First, get rid of any fractions by multiplying, or decimals, by multiplying by the LCD. Do not multiply inside parentheses. Get rid of parentheses by doing your distributive property. Simplify each side by combining any like terms on either side of the equal sign. Then move all the variables to the same side. Now technically, it can be either side, but for simplicity's sake, just because when we get to inequalities, we want them all moved to the left-hand side, we're just always going to move them to the left-hand side anyhow. Okay, as we get better at this and good at this when we're in college algebra, we can move them to any side, if we see something that might make our math easier. We're going to undo anything being added to or subtracted from the variable. Okay, to undo things, remember you perform the opposite operation. So if something is being added to your variable, you're going to subtract it, and you're going to do that to both sides. If something is being subtracted from the variable, you add it to incur a zero to both sides. Then you're going to undo anything being multiplied to the variable. And of course, the opposite of multiplication is division, so we would use division for that process. Okay, and then you'll wind up with x, whatever variable, x equals a number. And if we have an equation, you can always check your answer. Okay, so let's just start. Okay, you might want to write those steps down somewhere. You can go back and pause it and write them down if you need to. But let's solve a linear equation. Let's think through those steps. Get rid of any fractions. We do not have any fractions. Get rid of parentheses. We don't have any parentheses. Simplify each side. These are not like terms. We cannot combine them, so nothing to do there. Put all your variables on the same side. All I have is a p variable here, nothing over here, so they're already on the same side. Okay, so now to some actual steps we can perform. Undo anything being added or subtracted from the variable. Because I have a plus 4, if I do minus 4, as long as I do the same thing to both sides, right, this equation stays equal. Now plus 4 minus 4, that's 0. So over here I wind up with negative 5p plus 0. That's just negative 5p. And on the other side I have 19 minus 4, which is 15. Then undo anything being multiplied to our variable. Since I have negative 5 times p, if I divide by negative 5 to undo that multiplication, as long as I do the same thing to both sides, negative 5 divided by negative 5 is 1p, and 15 divided by negative 5 is negative 3. Now we've solved it. And we may want to, just to confirm, we may want to check it. Let's plug in a negative 3 everywhere there's a p and see if it makes the equation true. So negative 5 times negative 3 is positive 15 plus 4. Does that equal 19? Yes. Okay, so that's our basic steps. Let's look at another one. Okay, we don't have fractions. we don't have parentheses. Okay, there's nothing to simplify on each side because each side has unlike terms. Move all the variables to the same side, and I'm going to move them always, for now, to the left side. Because I have two x's over here, I do not want any x's on this side of the equation, so I'm going to take away two x's. If I do something to one side, I have to do the same thing to the other side, so I'm going to take away two x's from that side. Now, on this side, I still have the 5, but now I have minus 8x minus 2x, okay, which is minus 10x. And on this side, 2x minus 2x, that's 0. Sorry. And 0 minus 5 is minus 5. Okay, all my variables are on the same side, so undo anything being added or subtracted. So over here, I have a positive 5. So that means if I do negative 5 to make that 0, then I must do negative 5 over here. So 0 minus 10x is minus 10x. Minus 5 minus 10. Undo anything being multiplied to our variable, so divide by negative 10. So negative 10 divided by negative 10 is 1x, and negative 10 divided by negative 10 is 1. And don't forget, we can always check our answer. Let's plug in a 1 for the x. 5 minus 8 times 1 equals 2 times 1 minus 5, and I want to know, is that true? So is 5 minus 8 the same thing as 2 minus 5? Is negative 3 equal to negative 3? Yes. Perfect. Okay, they're going to get a little more complicated on us now. So we still have no fractions though, but this time we do have a set of parentheses. So we need to get rid of those parentheses by using our distributive property. So remember, multiplication distributes over addition. So the rest of the problem is going to stay exactly the same. So I have 11 plus 3 times x is 3x, and 3 times 1 is 3. The rest of the problem stays exactly the same. After you get rid of parentheses, simplify each side. In other words, combine any like terms. On this side, I have two constant terms, two just numerals without a variable, so I can add those together. 11 plus 3 is 14, plus the 3x. On this side, there's nothing I can combine. One has a variable and one has a constant. Okay, simplify both sides. Then put all your variables on the same side, and we're going to move them to the left-hand side for now, right? Always. So I have 14, and 3x minus 5x is minus 2x equals, now that's a big fat 0, 5x minus 5x, so 0 plus 16 is 16. Once your variable is on one side only, undo anything being added or subtracted. Since that's a positive 14, I'm going to subtract 14. That would make that a 0, right? But whatever I do over here, I got to do the same thing over here. So 0 minus 2x is minus 2x. 16 minus 14 is 2. Now undo anything being multiplied by your variable. Since it's multiplied by negative 2, let's undo it by dividing by negative 2, both sides. Negative 2 divided by negative 2 is 1. So 1x equals 2 divided by negative 2, negative 1. And I'll leave the checks to you now. But ideally, you should check your answer, particularly if you're on a test, right? Okay, let's see what else we have. All right. Get rid of fractions. There are no fractions. Get rid of parentheses. There is a parenthesis. Now be careful on this one. Remember, there's an understood 1 right here. So that's -1 that needs to be distributed. And -1 times 7 is -7. Be careful about a negative in front of a parenthesis. That negative needs to be distributed. Okay? Simplify both sides. So here's two terms that are alike. 4x minus 1x is 3x. Undo anything being added or subtracted to the variable. So let's add 7 because that would make that go away. But I have to do it to both sides. So 3x minus 0 is just 3x. But 9 plus 7 is 16. Undo anything being multiplied to the variable. So let's divide by 3 because 3 divided by 3 is 1 times x. And then 16 divided by 3 does not simplify any further. So I'm going to leave that 16/3. We could write that as a mixed number, but unless we are working an application problem or what you might call a word problem, we're just going to leave it an improper fraction, right? But if I ask you how many miles you ran, you're not going to say 16/3. You're going to say 5 1/3. But if we're just working an equation, we're going to leave it as an improper fraction. It's got to be reduced though, simplified, right? But we can leave it as an improper fraction because if we need that value in another problem, we're going to need to make it an improper fraction anyhow. Oh, now we have one with fractions, yay! Okay, so first step, anytime I see an equation, first of all, make sure it is an equation. You have to have an equal sign. If this was a minus sign or a plus sign, I could not do this step. I would have to get common denominators and make equivalent fractions and all kinds of things. The only way I can simplify these problems by getting rid of the fractions is if I have an equal sign. So, okay, yay! We have an equal sign. That means find a common denominator. The common denominator between 2, 4, 12, and 3, I hope we all know is 12. We'll do some review of that when we get to expressions, but if you don't know how to find a common denominator, you need to contact me or get on with a tutor or something. And how do I get a common denominator? And I'm going to multiply every term. Now remember, not inside parentheses, but I don't have any parentheses here to worry about. So I'm going to multiply every term by that common denominator. Every term, all the way across. Okay. And now, this is just one term. Remember, a term is separated completely by plus or minuses. I can't do this across a plus or a minus. But if all I'm doing is multiplying, then I can say, oh, 12 divided by 3, that leaves a 4. 12 divided by 12, they completely cancel. 12 divided by 4 leaves a 3, and 12 divided by 2 leaves a 6. So now when I go back and look at what I actually have for a problem, I have 1 times 4x. In other words, 4x minus 5, nothing else, minus 5, equals 3 times 3, 3 times 3, plus 1 times 6, and don't forget the x. And now look, voila, we have the same kind of equations that we've already been working with. Get rid of those fractions. It makes your problem so much easier. Okay, so once we've gotten rid of the fractions, then we get rid of parentheses. This problem doesn't have any parentheses. Simplify each side. There's no simplification I can do. Move all your variables to the same side. And we're always going to go for now to the left-hand side. 4x minus 6x is minus 2x. Everything else stays the same. And then 6x minus 6x, that's 0. So 9 plus 0 is 0. Okay. Once all your variables are on the same side, undo anything being added or subtracted to that variable. So instead of minus 5, we want a plus 5. Got to do the same thing to both sides. All right, minus 5 plus 5, that's 0. So this is negative 2x plus 0, or in other words, negative 2x, and 9 plus 5 is 14. Now undo anything being multiplied to the variable. Since it's being multiplied by negative 2, divide by negative 2. Both sides, because negative 2 divided by negative 2 is 1, so that's 1x, and 14 divided by negative 2 is negative 7. And once again, I'm going to leave the check for you, but remember, when we're solving an equation, you can always check your answer. Okay, let's try again. No fractions this time, but we do have parentheses. So first step, let's get rid of our parentheses using our distributive property. So that means we have 2. Negative 3 times 2 is negative 6. Negative 3 times 6 is negative 18 times z. Okay, 4 times z. Also, I'm going to make a comment to you. Right here, if you have a z, you should put a little line through your z. Yes, typically I can tell the difference between my z's and 2's, but by the end of the problem, I may not be able to tell which is a z and which is a 2. So the standard thing is to put a line through your z's. If you're used to doing that through your 7's, try to not do that anymore, right? Put the line through your z. So 4 times z is 4z, and 4 times 1 is 4, and then there's the minus 8. Do any simplifying you can do on each side, and I've got a couple of constants here, so I can combine those. 2 minus 6 is minus 4, minus 18z, and constants over here, no other z terms, so that's going to stay the same. 4 minus 8 is minus 4. Okay, now put all your variables on the same side, on the left-hand side. So let's subtract 4z, so there's no z's over here. But if I do it on one side, I got to do it on both. So I have negative 4 minus 22z equals 0 minus 4. Okay, once all your z's are on the same side, undo anything being added or subtracted to that variable term. So let's add 4z. That makes this 0 minus 22z. And over here, actually, that's also 0. Now, undo anything being multiplied to your z, your variable. So let's divide by negative 22. Because anything divided by itself is 1. So 1 times z is z. And 0 divided by anything is 0. This is a huge deal that's going to come up over and over in all your future math classes about dividing by 0. So just as a quick aside, if you haven't ever seen this before, okay, 0 on top of a number is like right on, okay. But a number on top of 0 is no, 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 no. That's the one we can't have, right? But if 0 is on top, that's okay, and it equals 0. We'll revisit that multiple times. You should have already heard a little about it. If you haven't, let me know. Oh, I see more fractions in our future. So make sure it's an equation first. So first of all, you probably get fractions. Oh, yes, equation. I'm getting rid of them. To get rid of them, look at the denominators. Our denominators are 4 and 3. So my common denominator, least common one, is 12. Multiply every term, not inside parentheses, every term by 12, not inside parentheses. So now we have 12 divided by 4 is 3. 12 divided by 3 is 4. And that's just times 12. So right here, we have 1 times 3, which is 3 times x plus 3, minus 2 times 4 is 8 times x plus 1, equals negative 2 times 12 is negative 24. Now, use your distributive property to get rid of the parentheses. So 3 times x is 3x. 3 times 3 is 9. Negative 8, remember the sign in front of the number is part of the number. Negative 8 times x is negative 8x, and negative 8 times 1 is negative 8, equals negative 24. Simplify each side. Here's some x terms I can combine, and there's some constants. 3x minus 8x, negative 5x. 9 minus 8, positive 1. Once all your x's, move your x's, but they're already on the same side. So once all your x's are on the same side, undo anything being added to the or subtracted to the variable. So negative 5x plus 0 is negative 5x. Negative 24 minus 1 is negative 25. Then undo anything being multiplied to the variable. So I'm going to divide both sides by negative 5. Negative 5 divided by negative 5 is 1. So x equals negative 25 divided by negative 5 is positive 5. Okay, no fractions, no parentheses. So first step in this problem is to simplify each side. 3x minus x is 2x plus 10. And over here I've got a couple of constants, right? So 2x minus 4 plus 14 is 10. Move all your variables to the same side, and now I want to pay close attention to what happens here. The variables disappear. 0 plus 10 is 10, and 0 plus 10 is 10. If your variables disappear, it's a special situation. There's 3 things that can happen when you're solving an equation. You get an answer, like we have been getting, x equals a number. Or there might not be no solution. Might not be no, I guess I shouldn't say that, right? Might not be a solution. You know, just because I write an equation like 5 plus 2 equals 12 doesn't mean it's true. So I could have no solution, or I could have infinite solutions. Think about 5 plus 2 equals 4 plus 1. That's always true, right? Always true, always true. So what if I put x plus? Well, any number I add is still going to make this always true. So our choices are, you get an answer, it's a bad problem and there's not an answer, or it's really the same problem and there's an infinite number of answers. As long as we work our problem down like we have been and we get x, or our variable equals a number, then we've got an answer and we're done. If our variables ever disappear, then it's one of these 2 cases. And I have to decide, Is it a no answer or an infinite number of answers? And if your statement you're left with is a true statement, then it's an infinite number of answers, right? Any number I plug in there to X would make this a true statement. And so, let's see, I'm going to look right quick and see what this text, depending on what text you're in, how they want you to leave your answer. And go back to the section that this covers, and we are going to call this wrong book. I don't have this book. Okay, I think we're going to call this, here's the symbol for all real numbers, right? It's an R with an extra leg on it. So all real numbers, or your choice might be infinite solutions. So what this is going to look like on your homework is it's going to have 3 multiple choice parts. And it's going to say X equals, and you fill in the blank. Or one selection is going to say all real numbers or infinite solutions. And the other one will say no solution. Right? And then you click this and fill in the blank. Or you click this one or you click that one. Okay, so we can already look by the title what's going to happen here. But recall, we're not going to know beforehand when we're solving an equation. So I got to know what I'm looking for. Because it's an equation, here's my steps, right? Get rid of any fractions. There's not any. Get rid of parentheses. So I'm going to use my distributive property to distribute that 6 and make that 6x. And then 6x times -1 is -6 minus 3x. Okay. And so then I'm going to combine like terms. Right? This side has some like terms. 6x minus 3x is the sign in front of the number that we're using. 6x minus 3x is 3x minus 6. Put all your variables on the same side. Okay, so 3x minus 3x is 0, plus 8 is 8. 3x minus 3x is 0, minus 6. Now, notice all our variables disappeared. Right? The variables disappeared. That means I've got to decide. It's either infinite solutions or no solution. And because 8 does not equal -6, that's a no solution. Now, on the test, you can leave this. Just like on the test, you'll leave that real number solution. But it might be written out no solution on your option for your homework. Okay, but this is the symbol, the empty set symbol, meaning there's not a solution. Okay, so if you wind up with x equals a number, you're good to go. If your variables disappear, you got to decide no solution or infinite solution, and it depends on, is this a true statement or not? If it's not true, there's nothing I can plug in here to make it true. Okay, if it is true, no matter what I plug into the x, it's always going to give me the same solution. Okay, so now we have a problem that has a decimal in it. It can be thought of like a problem with fractions in it, right? So, because decimals are fractions, remember? So 0.5 is the same thing as 1/2. But with a decimal, what I want to do to get rid of the decimals aka get rid of the fractions, is look at all my decimal values and see how many digits they have behind the decimal. These all have 1. So I'm going to move the decimal over one place. That serves the same purpose as multiplying everything by 10, right? So I'm doing the same thing. It's just with decimals, I don't have to physically think about it that much. Not inside parentheses, but every term must be multiplied by 10, which means this decimal will move here, this one will move here, this one will move here. So now, this is just 5 times 2 minus 3x. This is 45 if the decimal moves over 1, minus 1 times x plus 7. Okay, we've gotten rid of the fractions, aka decimals. Now get rid of parentheses. So 5 distributed through is 10 minus 15x equals 45, and distribute negative 1. So negative x minus 7. Simplify each side. Nothing on this side that I can combine. They're not like terms, but I got a couple of like terms over here. So this side stays the same. And 45 minus 7 is, what's that, 38 minus x. Let's put all our variables on the same side. So let's add x. We're going to put them on the left for now. So this is 10 minus 15x plus x is minus 14x equals 38 minus 0. Once all our variables are on the same side, undo whatever's being added or subtracted. So let's subtract 10 from both sides. 0 minus 14x is minus 14x. 38 minus 10 is 28. Undo whatever's being multiplied to the variable. So let's divide by negative 14. Same thing to both sides. So we wind up with 1x equals 28 divided by negative 14, negative 2. So we can also get rid of decimals, just like fractions, right? Okay, so here we are again. We've got fractions. Now, be careful. Remember, we cannot multiply inside parentheses. So this fraction in here is irrelevant to us right now. Okay, I need a common denominator between the 3 and the 6, which is going to be 6. So let's multiply every term, but not inside parentheses, by that 6. Okay, so 6 divided by 3 is 2. So let me, how about this? 6 divided by 3 is 2 there. That's better, right? 6 divided by 3 is 2. 6, there's no number here to divide out. 6 divided by 6, that's 1. It's just gone. So right here I have 2 times 2. So that's 4k minus 6 times k minus a half equals, and now 6 divided by 6 is gone, so there's the 1, k minus 51. All right, I still have a fraction here, but that's because it's inside parentheses. Sorry, guys. But now I'm going to get rid of the parentheses, and they're really nice to you on all your problems in this course. It's going to automatically get rid of that fraction too. So getting rid of parentheses, we're going to distribute. So we have 4k minus 6 times k, and then minus 6 times minus a half. Okay, a negative negative is a positive, and if I need to go over to the side and see what 6 times a half is, we could do that, or half of 6. right? But hopefully we can multiply fractions. So 6 times a half, or a half of 6 is 3. And then 1 doesn't change, k minus 51. After you get rid of fractions and you get rid of parentheses, you simplify each side if possible. And I've got two like terms here. So 4k minus 6k minus 2k plus 3 is k minus 51. Put all your variables on the same side. So there's not any k's left over there. Negative 2k minus k is negative 3k plus 3 is negative 51. 0 minus 51. Once all your variables are on the same side, undo anything being added or subtracted. So let's subtract 3 from both sides. So we wind up with negative 3k, and negative 51 minus 3 is negative 54. Now, undo anything being multiplied by the variable. So divide by negative 3. Divide by negative 3. That leaves us negative 3 divided by negative 3 is 1k equals a negative is positive, and 54 divided by negative 3 is, what's that, 18? If you have to go over to the side and do that, that's fine. And you can check your answer. Okay, so now the other thing in this section is translating a phrase into an algebraic expression. So if two numbers have a product of 36, I got to know what that means. Product means two numbers are being multiplied. Two numbers are being, and they're two different numbers as far as I know. Could be the same, x and y could be the same, but I got to write them that they might be different. So two numbers have a product of 36. When you multiply two numbers together and it equals 36, right? That's the same thing, this is the same. If one of the numbers is represented by x, find an expression for the other number. So if one of them is x, to get rid of this, to undo this, and this is kind of stuff we're going to do later too, then the other number must be 36 over y. Now this is how I come up with it, right? They want the other number, so they just want this part. They want you to just think about what that means. Oh, if they multiply and give 36, then the other one is 36 divided by x. Actually, I did this wrong because I want the other one, right? I want the other one. I want it to cross out the x, not the y. Okay, so we wanted to cross out the x because we want the other number. One of them is x. What's the other one? 36 over x. I hope that wasn't too confusing. I think we've got another. Let's look at that. Okay, because I might have just messed you up on that. Sorry, guys. Okay, so Monica is X years old. What expression represents her age 15 years from now? This one's a lot easier. If she's X, 15 years from now, you just add 15 to what her age is, right? 5 years ago, right? If she's X now, then 5 years ago is X minus 5. All right, one more, guys. If Cliff has R quarters, express the value of the quarters in cents. Well, 1 quarter is 25 cents, right? So I'm just going to multiply 25 times R. If he has 1 quarter, 25 times 1 is 25 cents. If he has 2 quarters, 25 times 2 is 50. He has 50 cents. So 25R. So I've got a few like that. Okay, if you have any questions, let me know. I'm here to help you. And I'll see you next time. Uh-oh, I lost my... Oh, I